Hi everyone, this video is on question 3 of exercise 9i of pure 2. So we have the function arctan x, and in this video I'm going to do part D. I've already done part A in the previous video. And so we have the function arctan x, and we want to find the points of inflection. So just a quick reminder that if we want to find the points of inflection, we first need to find the second derivative of the function. And then we need to check the behavior of the function just before and after that solution of f dash x is equal to 0. So that allows us to find to analyze the behavior of the function and see if it's a point of inflection or not. Because a point is a point of inflection where the curve changes from being a concave to convex or vice versa. So I'm going to show now. If you're not sure about that, don't worry, I'm going to show in this video. So now we have the function arctan x. The very first thing is, as always, finding the second derivative. So f dash x is equal to arctan x is one of those standard results that we can commit to memory. And I have shown in other videos that how to differentiate these types of functions directly, in cases that you don't want to memorize or you forget the formula. But anyway, f dash x using the standard results is 1 over 1 plus x squared. That's the derivative, the first derivative, which can be written as 1 plus x squared to the power of minus 1. The second derivative is, so this is the chain rule, minus 1 is the power that comes down. The derivative of inside is just 2x, and then we write down the bracket and then the power minus 1, which is going to be minus 2. So we can rewrite this as minus 2x over 1 plus x squared squared. So this is the second derivative. Once we get to this point, the next step is always setting the second derivative to 0 and then solve that equation. So in this case, we want to find a point of inflection. So the first condition is that f double dash x must be 0. So we have minus 2x over 1 plus x squared is equal to 0, and a cross multiplication gives us that minus 2x is equal to 0, which means x is equal to 0. Okay, now we have found one value for x. So this means there can be at most one point of inflection, because sometimes you get multiple values of x, and in those cases, that means you can have more than one point of inflection. But there is no guarantee that if you, for example, get 3 values for x, then that means you are going to get 3 points of inflection. No, because the second condition, which I'm about to show you in a few seconds, you'll see that sometimes some of the points will fail, and then that means they don't meet the satisfy the condition, so they are not a point of inflection. If you're curious about those cases that you get multiple values of x, I strongly recommend you to watch the previous video in which I solved part A, which is an interesting case. Okay, now we have the value of x is equal to 0. The next step, which is considering the second condition, remember the second condition of checking whether a point is a point of inflection is to analyze the behavior of the function just before and after that value of x and see if there is a change in sign of the second derivative. Because the goal is we want to check, so f double dash x, the value of x is 0, but just after that can be just that value plus 0.1, which is a very tiny value, and also just before that, which means 0 minus 0.1. So this allows us to see the behavior of the function, and then if there is if the value of f double dash x is positive in one of them and negative to the other one, or just simply they have opposite signs, and that means that this is actually a point of inflection, because the curve changes from being a concave to convex or vice versa. So that's the thing. But if you end up getting two same signs, both positive or negative, then that means this is not a point of inflection. So this is the second test that usually students forget. So they only solve up to here, and then they just say, okay, this is the point of inflection, but it's not always the case. Right. Now it's just a matter of substituting these two values into the value of f double dash x and see what we are going to get. So for the first value, which is f double dash x of 0 0.1, we get minus 0 0.1, we have 196, so three decimal places. And for f double dash x of minus 0 0.1, we get 0.243 decimal places. And this is exactly what we wanted, because one of the values is negative, the other one is positive. So since there is the change of sign, we can conclude that therefore this is the point of inflection. But before that, remember that this is the x coordinate of the point of inflection. We also need to find the y coordinate. So we just need to substitute x is equal to 0 into f of x to find its y coordinate. So f of 0 is equal to arc tan 0, which is just 0. So this means the point of inflection has coordinates 0, 0, or just the origin. So you can say, therefore, this is the point of inflection. And that's how you can answer these types of questions. So you just need to be very careful with your calculations and also checking that at the end. All right, that's it for this video, and thank you for watching.